the big data analytics infrastructure or architecture that we need to understand about what exactly the work or how the technology inside a big data environment that support the big data analytics works on. Yeah. So the purpose of this morning session is we will discuss and also give you some knowledge and also some information about the technical aspect of several technological methodologies or tools in the big data that used in the big data analytic processes that can support the use of the analytic itself. Yeah. So I think today we will have two sessions. The first session, I would like to give you some introductions about the some of the updating material for you. Yeah. So this morning I will discuss about mostly in the infrastructure first in the Hadoop. Yeah. So how actually Hadoop works. Yeah. The Hadoop as a platform, as a big data platform engine, and also algorithms to work on many tools that can support the big data analytics processes, from the data gathering process, ingestion, data storage, and also the other aspect like visualization and also analytic itself. And also we can see how the some algorithm like in the machine learning or deep learning will work on with the Hadoop ecosystem. And the next is I will let you to present your report about the evaluation or review on the of the technology that I think you already search, and also you already make some presentation or some small experience with your friend, and then you can share with us about that material. Yeah. So okay, I will update first about our material. So let me share with you. Okay, so what we will talk today is about the Hadoop. Yeah. Why we need to know about it? Because when we know about Hadoop, actually we won't focus on the characteristic of the big data platform or big data environments. So this is very important because sometimes we only see that you say when we talk about big data environment, our imagination is just like we have one node of server, our computer, and then we install all the stuff that we need to run a big data tools. Yeah. So we sometimes we just install like big data tools like AI engine like TensorFlow, Graph, and also another things. Yeah. So actually it's not like that. Yeah, because when we see a big data environment, so we need to understand about the very lower layers. Yeah, that we call the platform. Yeah. So the big data will be of course, because we talk about big data, we will talk about the distributed file system. Yeah. So this is like how we run all the tasks, all the loop in the distributed way. Yeah. So we try to give the opportunity to have capabilities on the speed of the data processing, and then also we can handle huge volume of data that we can process in one time, and also we deal with some many type of data that we can process in the one times. Yeah, in the same time. So maybe in the real time or in the batch type of processing. So that's why after we discuss about this Hadoop, actually we will learn a lot about how actually the model of the processing. We call the stream processing and also the batch processing. Yeah. So will be our discussion. So I have two slides actually. The first is the overview of the Hadoops. Yeah. Yeah, I think we only highlight that. Yeah, you know that we face this issue. Yeah, This is the volume, variety, veracity, and also velocity issue in the big data. I think I will not explain because we already explained previously. And this is the most important thing. So when we want to handle all these issues, these four issues, include the value, yeah, actually. So we need a platform, a specific platform that the platform can work as as environment for processing all that related with that issue. So that's why when we learn about a big data platform, yeah, the close solution is on the Hadoop, yeah. So we call it Hadoop distributed file system. But maybe you have a question. It is only this solution that can work for big data environment. It's only Hadoop, or we have another things. Um, yeah, what we think is actually it's not only just Hadoop here. We have a lot of alternative. We have a lot of option to do that one. So Hadoop is one of the most famous and also leading environment on the that develop on the big data platform developments. Yeah, it's also the first one. Yeah, the first one. So after that, we have a lot of platform actually. We have from Teradata, we have from Oracle itself. We also have the, like Pentaho itself, and also another tools. They have a lot their own platform to transmit the big data. Um, for example, in the banking industry, maybe Hadoop is not familiar because they already have the solution that we call the MarkLogic server. So it's kind of like a huge server, a storage server that have capability to have some logic data, metadata connection, and then they can proceed in the very huge data, especially for banking. Yeah, so that will be the one of the example. If we also have the Teradata. Teradata is one of the not only company. It's also company, but yeah, the solution or technology is very comprehensive. Yeah. They have a full pipeline of solution from the platform itself, and then how the tools to gather the data, and then after to process the data, and then to report or produce some business intelligence report on it. So that is the very huge landscape. And in the Oracle is also same. Yeah, even we know Oracle is like a database enterprise or a database company. Actually, he also have some of the technology. Oracle Big Data is one of the platform that work very good in the especially for support the very big or very huge database storage, yeah, for and then process into the big data platform. And let's say we have like IBM also, IBM with Watson solution, and then with I don't know the name, is forget the name. But IBM also have the platform. It's also work for their environments, and then in the cloud environment we also have same solution. Yeah, for example, the Amazon AWS, Amazon Web Service has also have a lot of solution for big data processing. In case they also deliver also the Hadoop based solution, and also the other solution. Microsoft with the Microsoft Azure is also have the same solution. So we have a lot of platform in here. So actually we have a lot of an option, yeah, Okay, I'm sorry, I have a lost connection. So wait a minute, we have a backup for connection first. Okay. Okay, sorry for the for the error. I think I have problem with the uh, connection, so I will try again. Okay, so okay, the last point we discussed about some of several example, yeah, in technology way about the existence of the big data platform, not only Hadoop. But today we will discuss more in the big data platform, which is Hadoop. And because actually when we learn about Hadoop, this is like, you know, this is the first point of on the early solution that exists for big data platform. And of course, because it is early, so they have some, you know, some foundation that used for many another solution that I explained previously. So actually, in the big data platform, there are two kind of the processing style, yeah, or processing type. And the first is batch processing, and then the second is stream processing. When you hear about Apache Spark, Apache Storm, and then Samza, this is one of the kind of the technology that work on in the batch processing and the stream processing environments. Yeah, we will discuss later, yeah, about the batch processing and then stream processing model, how it's work, because it's very important. Because let's say when you want to run like artificial intelligence based algorithms like deep learning on, or maybe for example the CNN or BNN algorithms, so you need to learn about how it will be processed in the big data environment, because it will be impactful for like your accuracy, the speed of the completion of the job, and also another things. Yeah, so that's why it's not only just we choose or we select the best algorithm that we believe in the based on the research, but also it's also will be depend on the platform or environment that we work on, or we run on it. Yeah, so that will be very interesting. Yeah. So I think based on this point of view, we have three potential research actually for you if you want to like go to seminar, or maybe you want to go to proposal, or maybe like you want to go to your scriptsy or your thesis. Yeah, so we can work on in this three research focus here. The first in the big data platform developments. Yeah, so we deal about the optimization, configuration in effective and efficient way for you know, for combining all the big data platform in one place. And also we can research on the batch processing experience, for example, and then also the stream processing experience. So it will be very good if you want to join this research focus, because it is also one of our research focus here, for collaboration with the between lab system computer and jaringan, and also rekayasa perangkat lunak and data. So it will be very good if we can combine. Yeah. So let's say let's learn from history. Actually, Hadoop is born by these two people. This is Doc Cutting and Mike Cavarella. They are the senior engineers, and also is very the best talent in the Google actually. They start the NUTS project, yeah, in 2002. Yeah, and then based on the NUTS project, because you know, yeah, Google is one of the company that really give some space for the employee to have their own project, and then if and they will have a time and place for present in the front of all the people. If good enough, and then if very impressive, it will be pushed by Google for one of the technology developments. Yeah, so they will have some, you know, some very principal support from the Google itself. Yeah, and in 2003, Google published Google file system architectures. Yeah, in the paper actually. So based on the NUT project, they think about the distributed file system actually. They call Google file system. In 2004, they developed and also released the NUTS distributed file system. Actually, this project is like, you know, is combined. Yeah, the first is NUTS become distributed file system, and then in the Google file system step, they introduce the map reduce. Yeah, the map reduce algorithm. Yeah, for dealing with the you know, distributed workload and balancings. Yeah, so that will be, this is the actually 2004. This is one of the big milestone for big data platform. Yeah, especially for Hadoop developments. And because it's promising, and the Google, and then they become their own project. Yeah, Hadoop project started. Yeah, this is inspired and combining the NAT distributed file system and also MapReduce in one place. And so that's why we have the Hadoops here. And because it's now is, you know, if technology is very the solution or innovation on the Hadoop is very interesting and very, you know, open the landscape, the new landscape of the distributed file system. So that's why is merged into the Apache project, and then he become the top level project in Apache. And then yeah, in that time in 2008, Hadoop broke the record in the fastest system to sort terabyte of data. So this is most fastest you know system that can sort terabyte of data in the very short time. It's defeat the supercomputer itself. Yeah. So this is like, you know, some of the proof that very interesting to use the Hadoop. But you need to know this is actually sometimes I have a discussion. If we use Hadoop, it's mean all the kind of the, you know, all the kind of the data can be short in the very fast way. But actually we in this time we need to say that it's not like that one. Yeah. Because the Hadoop itself has a very unique, you know, unique style on the processing. So that's why it's only work for short terabyte of data in this time, yeah, in 2008. So from the starting, so that's within the nature of the Hadoop. Hadoop very in the MapReduce is the style of the algorithm is very close with the sorting things or sorting activities. Yeah. So that's why it's very important for us to see this point of view. And of course, Hadoop become major, and then is now developed by in a lot of way. Yeah. So that's why you can find the Hadoop officially in the Apache Hadoop. Yeah. And then if you want to use in the native format, yeah, I think you can use the Hadoop Apache. I'm very like to always to have this Hadoop Apache, because you can see the originality of the Hadoop. Yeah, it's not customized. It's not customized yet, and then it's not like we have some cosmetic on the feature and so on. So it will feel very pure. So that's why we use it. And then we also the Cloudera. The Cloudera is also one of the you know, some of the you know, new platform that use Hadoop as baseline, and then they customize based on their you know, their perspective, and then the purpose, and then they have a specific purpose for the Cloudera. But unfortunately, Cloudera now become the big one of the big data platform under the Hadoop. Yeah. So that would be very interesting. If you remember, like in the open source operating system, for example, we have CentOS. Yeah, oh, not CentOS. The previous one is Red Hat. Yeah. After that, Red Hat will be developed and customized, and maybe you know, enhance the technology inside. And then we have CentOS now, and then after the CentOS we have a lot of another things. Yeah, Fedora and also another operating system. And then Yahoo is also have the Yahoo Hadoop. Actually it's promising in that time, but unfortunately Yahoo now declining, I think. Yeah, so it's not, maybe you're not familiar again with Yahoo. Yeah? In my age, Yahoo is one of the very, you know, very leading, yeah, like Google. And then we have also cloud support. This is came from the Amazon. Yeah, they have the solution that called Amazon Elastic MapReduce, and also the Google also the same things. Yeah, Google Cloud Platform. Yeah, so that will be the support for the Hadoop. So this is like the Hadoop ecosystem. Yeah, this is the Hadoop ecosystem. We have you can see in here. You will familiar with the word. Yeah, we previously Hadoop, Notch, and then we have also Spark, and then we also have Hive, Scoop, and then Mahot. Yeah, Solar, and also the Edge and also Zookeeper. This is like one of the. It's also this one is in the peak. Yeah, this is like, you know, the environment of the ecosystem in the big data platform. So let's go to see the Hadoop. What is Hadoop? Hadoop in the architecture have several main component. Yeah, the first component is Hadoop common. This is the place where the original Hadoop Hadoop operating system is in here. Yeah, so you can see this is the the how the Hadoop work will be in this place. Yeah, this is will be the baseline and the environment, the basic environment of Hadoop that used for for running the other component of the Hadoop. Maybe when you say like in operating system we have a kernel, yeah. So this is the kernel of the Hadoop actually. And then the next is we have a Hadoop distributed file system. This is the file system or mostly like operating system. Yeah, in this component, Hadoop can manage and can arrange and coordination, do some coordination on the how they can work together in many nodes here. So if we place Hadoop in several nodes, they can work together as one single system. So that will be the Hadoop distributed file system function to manage all that kind of activities. And then we also the algorithm. This is actually MapReduce is the algorithm to do the big data processing, yeah, using the map and reduce algorithms. And then the rest is we also have the yarn. Yarn is like platform for or feature to manage the resources and deal with some of the hardware. Yeah. So that's why based on this component actually Hadoop become the framework for distributed storage and processing, and on cluster environment, but can work on the commodity hardware. So if you have at least, for example, I have experience running on the Pentium 3 or Pentium 4. Maybe you already doesn't have that hardware, yeah. But I still have that hardware. We can work. Hadoop can run there. If we want to run in the Raspberry Pi, for example, in the lab, we also have about 33 nodes of Hadoop distributed file system using the Raspberry Pi. Yeah, so it also can work in there. Yeah, so that will be the challenge for us. So that's why the Hadoop is state as commodity hardware environments. Yeah. So this is the architecture of the Hadoop. Yeah, Hadoop. Yeah, because this is basically is Hadoop is like distributed file system. So it's mean in the work of the Hadoop, we need two main component. The first component is master node, and then the second is slave node. Yeah, the master node will be the head of the Hadoop environment. We have a lot of job. Yeah, in this point we have a lot of job. Yeah, because in the master we not only just accept the job to execute, but also we need to deal with some of the monitoring activities that slave ready to have the job, how the progress of the work of the job, and then maybe like do some activity to handle if we have something wrong in the process. Yeah, so that's why we have the master and slave here. The slave can be more than one. It can be 2, it can be 4, it can be 8, it can be 16, 32, 64, 1 to 8, and etc. But at least is to n. Yeah. So we need to add the node in the replication way. Yeah. So that's why in here, in the Hadoop architecture, we have in the operating system, we have two layers. The first layer is MapReduce. This is the layer that deal with the distribution of job, yeah, distribution of job from the master to slave. And the HDFS layer or Hadoop distributed file system layer is deal with the configuration of the cluster or configuration of the many nodes here. So that's why when we see in here Hadoop distributed file system layers, we deal with the multi-node cluster. It's mean we will try to manage and arrange several nodes of the computer work together and will be tied by the master node. So we have two kind of node, yeah, master node and also the data node. But in here, the unique is the master node is also being a data node. So the master node is also work as data node. Yeah. So in here, but we have like a configuration. The first is in the master node we have a name node. Yeah, name node is mean we naming all the node that will be our in our arrangement, and then we will have we will mark all the data node, and then all the data node will be under the coordination of the name node. Yeah. So what the mean of this? And the mean of this is the master node will be known very well about the how many nodes that connect with us, and what the status, what the progress of the execution of job, and also we know the healthiness of the node. Yeah, if the node is busy, if the node cannot accept the job, they will know. Yeah, so it is like actually when we learn about distributed system, or yeah, system terdistribusi, distributed system in the cluster way, in the grid way, is like that. Yeah, it's same like that. It's mostly like network management, and also in here. Yeah, so that's why when we implement the Hadoop in the multi-node cluster, or in the multi-node server, we need to make sure that all the node is in one environment of the network. Yeah, at least in one LAN. Yeah, in the local area network. If you decide, for example, in one lab, yeah, for example, in our lab, in lab system komputer and jaringan, for example. But if we want to duplicate, we can do that one. So for um, on top of the network, we can communicate with another node. For example, I place in lab computer network and network, and then I also place several nodes in the physics, yeah, department, in chemical, and then we can work together. Is one single big node, yeah, in the multi-node cluster, so that we can do that one. Yeah. So that will be the interesting. So how we manage all these things, yeah. So that will be your first option, or maybe your first potential research topic that you can bring as your thesis actually. So if you like that one, actually, I'm very interesting to discuss about that for your research thesis, yeah. Because now we plan to do that one. So we not to invest about, like, say, a, a bring the hack specification of computer, yeah, that will be very costly. But how if you're using the commodity server from many department? I think our department, for example, in our department, yeah, in computer science and electronic, I think we have a lot of computer, yeah, more than 100 computers, and in the physics also same. So in one our faculty, maybe we will have about 1,000, maybe 100 or 1,000 computer. How if we try to borrow the resources, not in the peak, not in the working hours, but for example in the night, for example. But we try to arrange as a data node for in the Hadoop ecosystem. So in one ecosystem of Hadoop, of faculty of natural sciences, for example. And what we have, we have a very we have a 1,000 supercomputers that work together as Hadoop distributed file system actually. Yeah. How and then we arrange in one network, yeah, in the same network. How if we try to figure that idea, how if one UGM we can do that one. So I think we will have the first supercomputer in Indonesia, yeah, because I think in the UGM we maybe more than 3,000 computers, I think, yeah. So that will be very potential to do that one. So yeah, so that's the imagination, yeah. And then in the MapReduce, the master, we will, for example, if we have some load, yeah, some job, yeah, the job will be administered by the master, and then the master will be, make some job tracker management, and then the job tracker will be, distribute the job into the node, into the slave, yeah. So but to distribute the job, the master need to know about the readiness of the slave. If the slave is for example is ready to accept the job, yeah, the job will be transmitted then. And then after finish, yeah, he will report the job is finished, and then the slave will be labeled as idle, and then it's mean ready for accepting the next job. So it will be like that, the process, but it's very in the rapid way. It's very rapid way. Yeah. So that will be the challenge of the Hadoop architecture. So when we see this one, Hadoop distributed file system actually have very typical way, very typical characteristic, yeah, to do that one, yeah, because this is adopted from Google file system. In the Hadoop distributed file system, by default, Hadoop will be store data in redundantly, yeah. So the data will be replicated in many nodes, yeah. So in the multiple node, and why? Because we try to gather the persistency and availability of data. So using we replicate all the data in the multi-node. We want to address that there is no single job that will be lost, no single job that will be not finished, something like that. So that means no persistency. And in some way, the data will be available in the many nodes. So it's mean will be very very enjoyable, and then for computing facility to transmit and also to process the data. So that's why this Hadoop distributed file system have the typical usage here. This is actually is work well for huge file. So if we have a file like 100 gigabyte into the terabyte, it will be good enough. If we have less than that, yeah, actually Hadoop distributed file system will not have a good performance. Yeah, it's not very maximum. Yeah, so that will be the problem. And data will be updated in the place, and then reads and append are common. Yeah, so that will be the typical usage. So based on this guideline, it means you have opportunity to see that if you have any question, why you use Hadoop. Yeah. So the reason is you go back to your characteristics of the data, and then you see the same pattern or not. If you have a same pattern, same like this pattern, it means yeah, it's worth it. You use the Hadoop. Yeah, so that would be the challenge. Yeah. So in the distributed file system, actually in every node, yeah, we make some of chunk server. Yeah, we have chunk server in here, and then we have a lot of chunk in here. Yeah, so you see in C0, C1, C5, C2 is represented the chunk. Yeah, because the chunk is from the place for storing the data, keep the data, and across the machine. Yeah, across the machine. So you can see in here. A lot of C1 will be placed into the chunk server number 1, and then go to the server number 2, and etc. So it's like replicate on the different machines. Yeah. So that's why it's very good performance on the computation of the data. Yeah. So that would be the next one. And what is the typical of chunk server? Actually, chunk server is like a data block. Okay, sorry, a little bit error on the connection again. And then the chunk will be, will be replicate in the different racks. So it will be the replication. It will be like not in the same rack. So It is like, you know, for the reason for availability. So if we have any problem in the one server, we will not worry, because we have a guarantee that we still have the data in the different racks. Yeah. So we also have the master node. This is the master node that I mentioned before. Is used as a name node in Hadoop distributed file system. It will be used for store metadata, and the metadata will be have information about where the file are stored. Yeah, and also could be replicated, and also we have a file access. Yeah, this is will be talks every work will be talked by to master node to find where is the chunk server, and then connect directly to chunk server to access the data. So we need to have we need to communicate with master data, and then go to the file access, and then we will see where the data is placed in the chunk server. So that will be how the distributed file system is work. Yeah. And if we talk about MapReduce, it is like simplified distributed programming actually. It's have two kind of algorithm. The first is map, secondly is reduce. Yeah, so that would be the two function. So the MapReduce, the logical way is like if we want to do some word count, counting the words, yeah, from huge stack of documents. Yeah, so we count the number of time each distinct word appears in the file. Yeah, so that's how the logical way. And then for real application, it's commonly used for analyze web server log to find popular URLs or links. Yeah, and then do some term statistic for search and etc. So actually, how the MapReduce work? Yeah, the MapReduce work is like we have at least about three steps. Yeah, the first step is in the map function. We do one of the big job first. Yeah, this is scan input file record at a time. So we do some scanning first. Yeah, and so for the scanning, the purpose is to collect all the information that the content of the documents, or some file, or maybe another object that we need to scan. And then after we scan, we try to extract something we care. Yeah? You care about from its record. That means we have a key. Yeah, and why it's very important. We need to produce a key, because we need to, based on the key, we will do the sort and shuffle. Yeah, so that will be very interesting. And then after we do the sort and shuffle, we can do the reduce. Yeah, the reduce will be do some aggregation, summarization. It can be filtering and also transformation, and then we do the result. Yeah, so that will be how the MapReduce work. Yeah, if we can see in this diagram, in the pictures, I think we can see that the most important thing is in the first stage that we need to have a key. Yeah? And the key, it will be it's like in the database, like in the primary key, I think. Yeah, but actually it's not equal, but yeah, for logical things like that. And then we have value, so key we will have value. So and then we will do the mapping process. Yeah, and then for the mapping process, we will try to find what is the the intermediate key that have a value pairs. So we do the mapping process, and then after that we try to group the key, because we believe that in the intermediate key value pairs, maybe we will have a lot of duplication. We will have same word that we found in the documents, and then we can do the group by key. So the representation of the one unique key can be represent the several value. Yeah, so that's why, because we have a several value that's same in the one key, in that time we can do the reduce. So in here we will have very key output of key value pair that very unique for each of the key and each of the value. So that's why we can counting how many words that unique that exists in the documents. Yeah. So that's how the MapReduce works. So if we represent in the some annotation, it will be like this one. Yeah. So the input is a set of key value pairs, and then it will be take key value pairs and output a set of value pairs, and we can call map for every key and value pairs. Yeah, and then we can do some reduce on the value that have some unique and same key are reduced together. Yeah. So in one reduce function, we can have a unique key, yeah, for this one. So that would be very easy to understand about the map reduce. So actually, when we learn about it, actually we can implement the algorithm of MapReduce in our own language program. Yeah. So if you can make this logical algorithm, the logical of algorithm, and then we place in the Java code, or maybe in the Golang code, or maybe in the Python code, is also it can we can do that one. So that would be also the interest part if you want to do some of the thesis for you. Yeah, so that's why in here we can see this one. Yeah, so this is the map reduce. We have big document, and then we try to do some mapping. After we have the mapping, we have the group by key, and then we reduce. Yeah, so that will be the we have the process of the map reduce work. Yeah, so it's mean this illustration is bring you that the map reduce is not like, you know, the library that only we can run and then we can read the result immediately. But the most important thing is like you understand the logic way, and then you can use it for your own algorithm actually. Yeah, based on you of course based on your, you know, your object that you want to analyze. So this is the screw code for from the MapReduce. I think we can sweep. And then the next is Yarn. Yarn is yet another resource negotiator. This is like the resource management feature that the focus is try to negotiate the availability of the resources. So when we do the big data processing in the multi-node cluster, there is no issue about the availability of the resources. Yeah, so that would be the general purpose of this yarn. Yeah, especially when we have a very massive MapReduce you know, load in the cluster. So it will be very important to understand this one. So this is like try to you know, to avoid the failure. Yeah, and then of course it will be have deal with the limited scalability. Yeah. So this is like the yarn. The yarn will have a sum of we call two major function. The first is global resource manager. It will be the duty is as a resource management. Yeah, so he will deal with a lot of you know, on the availability of the resource that can support the computation on the MapReduce. Yeah, he will very care about the availability of the node, what is busy or not, idle or not, if we have problem on it or not, and then how we increase the job distribution and how in efficient way and so on. So that will be in the deal of the global resource manager in the yarn. Yeah, and we also have the application master. The application master will be do some job scheduling and monitoring. So you can see that you can think that when master node distribute a job, it's mean not the job is like, okay, just do it, not like that, but we also arrange some time management or monitoring. Yeah, so the master will wait if, for example, in 1 minute the job is finished or not. If not, in that point, the master node will be say, okay, it means the slave node is not work well, so it means we can skip, and then we distribute the job to another node. So that will be how it works. So we will not wait until the job is done, but we will wait based on time. If the time limit is passed, so it means we need to redistribute the job to another. Yeah. So that will be a very crazy way actually when we see the yarn. So yeah, I can say that this is why one of my focus, yeah, actually in the research is I go to the resource management. So it's in the big data architecture, because I believe if we have a good resource management, it means the work of Hadoop and especially the MapReduce and other algorithm will be smooth. Yeah. So that's the important point, yeah, actually. Yeah, but what I want to say is very limited student that interest in here, yeah, not a lot, yeah. So maybe I have 20 students that interest in cloud computing, Okay, I'm sorry. I need to change the browser. I think. Okay, have problem. I think with this. Okay, wait. Oh, I think we have the screen. Yeah, okay, great. Okay, you can hear my voice clearly.
Yes, sir.
Yes,
Okay,
sir.
okay. Sorry for inconvenience, yeah, condition. Okay, so I will continue for our discussion. So this is okay. So we already discussed about the task tracker. Yeah, so that will be one of the function on the yarn that work as node manager, that the duty is to launch the application container and then monitor the resource use and reporting to resource managers. And this is the yarn works. Yeah, so you can see in here that a resource manager will be in place in the master node, and then he deal with a lot of application master in this is a job tracker, and then he will communicate with node manager and also the application master and the containers to see that what the condition every nodes. If they busy, they have idle, so it will be automatically the resource manager will know, and then he will he will he will act as manager that distribute the job. Yeah, on the so this is will be very interesting actually, because in this point we have opportunity to do a lot of algorithms. Yeah, for example, like the QQ algorithms. Yeah, for let's say using the scheduling algorithm, first in first out the algorithm, and also the prioritizations commodity based algorithm, and also another algorithm that can use by resource manager to distribute the job in the good way. Yeah, so yeah, and the yarn itself is also try to avoid the fault. Yeah, so that's why yarn very focused for fault tolerance and availability purpose. Yeah, so that's why the global resource management manager have the duty to make sure that there is no single point of failures. Yeah, so that's why we have a zookeeper too, and also make sure that application master are restarted automatically if we have some problems. And also the application master will be do some optional failover via application specific checkpoint. Yeah, and also make sure that MapReduce application will be picked up when they left of via a safe state in HDFS. Yeah, so that's why yarn will be focused on the fault tolerance and availability. And of course, from the yarn, it support a lot of programming paradigm from Spark and Storm. This is like stream and processing and batch processing programming, and also of course the graph processing. Yeah, this is the new one actually, the graph, yeah, graph processing. Yeah, so this is the reference. Yeah, I think. Yeah, so that would be in the introduction in the Hadoop. So if you want to install the Hadoop in the very easy way, you can access our operating system. Yeah, the OS, the cloud.wg.ug. This is our first operating system that produced by me and student of the laboratory computer network and system. We already have this one. So if you install, you download and install, and then you for example you install in your VirtualBox, you will already have a big data environment ready, and so you can add as cluster, and it's already fully optimized, so it's not like a very heavy or weight operating system, and also have a lot of automation, so you doesn't need to configure the big data, but it's already will be configured in automatically way. Yeah, so that's very interesting if you like. Yeah. Okay, so that's will be, so I invite you to, this is will be our actually one of my my focus on the research and development. So in the lab, yeah, to enhance the capability of this operating system. Yeah, so if you like, you can join the discussion. And I have a discussion session today in 12:30. If you like to join, maybe just for idea shopping for you, you can contact me via WhatsApp, and then I will give you some link to join. Yeah. Okay. So this is our my update material for today. So let's go to the presentation. I think it's time for you to present what you has done with your friend. Okay. 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 So let's say